Hello and welcome to my presentation about inheritance, and this also serves as an introduction to object-oriented programming. The intended audience for this presentation is Year 11 computing students in VCE and also Unit 3 and 4 software development students, probably more Unit 3 and 4 students. I confess that I don't really use the object-oriented features of programming languages when I make my own stuff, but it's on the study design, so let's get our head around it so that we can use it in our project, which is how you get the best possible marks in your SAT, and also be aware of it for the exam. So, students can explain the general concept of object-oriented programming, often just referred to as OOP, and abstraction I've said there, but in actual fact this is about inheritance. So, this image here is actually a pretty good place to start. So, object-oriented program, as the name suggests, deals with thinking about objects or concepts and trying to deal with them in terms of, well, we've got vehicles and we've got cars and we've got this particular type of car, or we've got employees, so we've got a school principal and we've got teachers and we've got education support, and saying, well, these things have relationships to each other and there's efficiencies to understanding the relationship between particular objects rather than just writing out a simple set of rules and decisions and so forth. So it's a way of thinking that organises software around data and objects. So it focuses on creating reusable, so we can say, okay, well, we've got a different sort of employee, we've already got all these conceptual stuff around employees, and that it connects itself to the real world, that it's less abstract, I guess. The four main concepts are inheritance, which is what I'm going to be talking about in this presentation, abstraction, which is going to have its own presentation, likewise generalization, and encapsulation. You also see polymorphism mentioned sometimes in this, but that's not mentioned in the study design, and I think that this is complicated enough as it is. So, when we look at this picture here, you'll see that the parent class there is a vehicle, and a vehicle has wheels, and it has an engine, and it has a body. And then we have the children of that, which are a race car, which has a spoiler and a high-speed engine. So instead of having an engine, it has a high-speed engine, but it still has a body and wheels. So it can inherit some of those characteristics, and it redefines some of those characteristics. Likewise, an SUV has, I'm not sure what that word's meant to be at the end, but it has large tyres, and then we have a delivery truck which has essentially all different things. It really isn't inheriting much from it. So in actual fact, that example is probably of limited value. So we establish a hierarchical relationship between them. We say this one up here holds the things that is true of all of these people. So if we were talking about employees, we'd say, well, it's true that everybody's got a date of birth, it's true that everybody's got a job description, it's true that everybody's got a starting date, it's true that everybody's got, a salary structure. Everybody's got a desk that they're located at. And then you'd go into the various different types. So this one up the top of employee, that would be your parent or superclass. Then you have your child classes. Now a child can itself be a parent of a further class. So we could say we have up here employees, then we have teachers, and then down here we have science teachers, and we have PE teachers, and we have computing teachers, and they are children of teacher, and teacher is a child of employee. But I don't want to get too bogged down in that, but children can be parents too. Now, a child automatically inherits most of the attributes of the parent. Unlike in real biology, where you get stuff from both of your parents and you get a sort of 50-50 split, you're a perfect copy for the most part. There's a couple of instances to do with permissions where you're not, but most of the time you get most of the things. You can then change it. And you can say, okay, I start off as a perfect copy, but now I'm going to have, I'm going to have front wheel drive instead of rear wheel drive. I'm going to have, teachers going to have their teaching degree, which is different than the qualification up there. I'm not doing a very good job with this example. The child class can then have additional qualities and different different ones. We can kind of overwrite them and say, no, I'm different from my parent in these ways. So let's have a look at it in practice. It gets a little bit woolly, but stay with me. I'm going to zoom in a bit. So here is our class of vehicle. This is a parent class. It has no parent itself. This def init is to initialize a vehicle. So we're saying it relates to itself. Don't worry too much about that. That just means this is to do with this class. And we're saying when you're created, you're going to have a brand and you're going to have a model. And self, again, is pointing to itself. I don't deeply understand this. And brand and model. So they're going to be the variables that are holding it. And we're going to have a method, and a method's just like a function that's going to say this is a, Toyota Yaris. So that's the parent class. What I'm actually going to do is I am going to take out all this other stuff and try and run it, and I suspect that it won't say anything. But let's have a quick look and see what happens. So there we go. In fact, it runs. Yeah, it runs, but it doesn't say anything yet. Okay. Well, let's get everything else back. Okay, so now we've got our child class or subclass, which is going to inherit from vehicles. So again, it's a class called car, but in brackets, this time I'm saying vehicle, which means, hey, my parent is the vehicles. When you create something in my class, I think it's called an object, when you initialize something, we're pointing back to myself, brand and model, well, we got those from our parent, and also doors. So we're getting these two from our parent. From our parent, we're saying, hey, let's have their attributes of a brand and a model. And something that's unique to me is I'm going to talk about doors. I'm also going to have a function that my parent didn't have called open trunk. So down here, this object, my car, we're creating this object. We're saying, hey, go talk to the class called car and give it these three arguments. It's a Toyota, Corolla, and it's got 4 doors. We're going to then go and say, for this object, go and talk to the method called display info. Now you'll remember that this method actually belongs to the parent. So that got inherited down into the subclass. Even though I made it with the subclass, it's still got access to this because it is a child of that parent. So it gets to use that because it's a child. And then I'm going to choose a method which is my own, which just belongs to cars. So these 3 will work. That creates the instance. I think I called an object before. It's an instance. That creates the instance of the car. This displays the model, the information about it, which it can do because it inherits that ability from its parent, and this is a function or method all of its own. So here we go. This is a Toyota Corolla. Yes, the trunk is now open. So it did all of those things. Now, if that's a little bit confusing, that's okay. You've got every right to feel confused at this point. But in short, we generalize up here, or we go to the highest level of abstraction. I think it's called generalization, actually. Yeah, we look for the highest level at which things can be true, and then we go down to classes below that to specialize, and then we can break out instances of those classes when we need to.